All right, so this problem is saying, okay, we know how much dye we have. We know what our mass of dye plus fiber is. What percentage of our dye bath is our water? And so we established that based on the fact that we had a 20% weight of fiber target with 250 grams of fiber, that we needed 50 grams of dye to get us a 20% weight of fiber solution. So we know that the mass of water plus the mass of dye is equal to 500 grams. We know that 50 grams of that is our dye. And so in theory, we would also have what we need to solve for our grams of water. In fact, we could do that. So if I know 500 grams of water plus dye is equal to grams of water plus 50 grams of dye, I could subtract 50 grams from both sides, and I get 500 grams of water plus dye minus 50 grams of dye is equal to grams of water. So that means I am going to have 450 grams of water. Now we're going to file that one away because we're not going to use it quite yet. But to solve A here, what we would do is the relationship of the mass, of the mass percentage, is the mass percentage of dye in our dye bath is equal to the mass of the dye in grams divided by the mass of the dye bath, which is also equal to water plus dye times 100%. Now we can go and we can see, first of all, do we need to rearrange? And then we can start plugging in. So we're solving for the mass percent of our dye bath, and our equation is set up. So we're solving for mass percentage of dye in our dye bath. So we don't have to rearrange, but we can start plugging and jugging here. So I know I'm solving for my percent of my dye in my dye bath. And we calculated in the previous problem that we had 50 grams of dye. And then in this problem, I tell you that the mass of your dye bath, so water plus dye, is 500 grams. So you're literally just going to take that 500 grams and you're going to put it in the denominator. So we know we have 500 gram dye bath. All right. And then we multiply that by 100%. So what we're going to end up doing is 50 grams divided by 500 times 100%. So 50 divided by 100, or 500, is going to be 0.1. So that's going to be 0.1 times 100%. That's going to give me 10%. So that means my mass percent of dye in dye bath equals 10%, or the mass of our dye is 10% of the dye bath mass. All right, so we're to highlight the answer, 10%, and that's just another way of describing our number. So now I'm going to flip over to our second question, part B, which is saying how many milliliters of water did you add, assuming water has a density of 1.0 grams per ml. So before we complete this math, let's take a minute and remember that we decided on the previous page, we know that we added 50 grams of dye, and we know that we added 450 grams of water. So in this problem, if you didn't already solve, you would solve for grams of water, which you would get from grams of dye bath minus grams of dye. And we know that that's 450 grams. Now, a lot of the time, in theory, it would be perfectly cool to just stop here and be like, okay, 450 grams of my dye bath was from that. However, the way we measure mass is using an analytical balance or a top loader balance. How do you think that weighing out water on a balance is going to go? You can do it, but it's not the easiest way to measure water. The easiest way to do it is to use like a graduated cylinder. So we use volume as our measurement instead. And what's great about density, which has units of grams per mil or mass per volume, is that it allows us to interconvert between mass and volume for a liquid. Now, in theory, we could do a solid tube. I don't want to think about solid packing. When we're talking about density, we're usually thinking about liquids or maybe a gas. So in this case, what this allows us to do is this is allowed to say, hey, I have 450 grams of water. I want to figure out how many mils of water I have. Density is our conversion factor here. So we can set up the density. So we put grams on the bottom, so our grams cancel. We have mils on the top, so our unit ends up in mils. And we want to put our number goes with the grams because our number's on the top with grams. So we would put 1.00 down here, grams per mil. So we would essentially be dividing 450 by 1, which is going to give us 450 milliliters of water. All right, so I hope this was helpful.